.gov came for. In today's session, it's going to be a little bit different from previous session. What I'm going to show you is a 100% practical and workflow-oriented approach into demonstrating Python. Today is the second session. In this session, I will show you how to work with digital well log files. Because this format is so common in oil and gas industry, unfortunately, most people do not know how to deal with them outside the environments of the commercial or the paid softwares. So hopefully, in today's session, I'm going to demonstrate some of the basic things that you can do and some of of course, the advanced things that you can set up. So what I want from you guys is what I'm going to demonstrate, it's going to be a little bit on the faster side. So this is not going to be a slow type of demonstration, because what we want, or what's the target of these types is to get you like the basic idea of possible workflows. It's the main idea is not to teach you how these things are done step by step. We want to convey to you the basic ideas and what are the possibles and what are the limitations. So please bear with us. Meanwhile, Mr. Nakhil, during the session for 10 minutes, like if you can open the chat box for people to ask like technical questions, please. Please try to ask only technical questions. This is a technical question will help us to guide these types of webinars a little bit better.
Sure.
Okay, so yeah, I think we're good to go. We're good to go. Okay, so let me show you a few things. Number one, well logging files is a very common data type that we find in oil and gas industry. So the problem with this data type itself is the data type itself is something known as a flat file. A flat file is basically a file that does not contain any information outside the file itself. So text files, LAS files, those are flat files. Excel is known as a rich file. Okay, so the problem with LAS file is actually it contains information, or it contains header information within the file. So it contains two parts of information. So let me just show you an example. The first, or actually we have many sections. So the topmost section, this is known as the header section. It contains lots of information about the wells, about the field, about the personnel, about the logging condition, the mechanical casing setup, or the mechanical properties of these casings, like internal diameter, the setting depths, and whatnot. And the second part of these files starts with the A, which is known as the ASCII section, which basically contains all the files that you need to get things working. Okay, so this basically contains all the information that was logged against depth. Now, if you're working with a single LAS file, what I'm about to show you, it's actually you don't need to do the things that I am doing if you're working with a single file. But if you start working with multiple files at the same time, which is quite often the case mostly, then you need the workflow that I am going to show you, because the workflow I'm going to show is actually it's going to alleviate some of the pain. It will give you some free time. And most importantly, you will get a code that basically automates things for you to use in later cases. Okay, so let me state the problem. So in this example, we have a folder that contains more than 260 log files. Now, do you see those files? Those are all LAS files with different sizes, different depths, and basically everything is different about these. The only thing that we are certain about is these log files are coming from the same state in the United States. Right, so this is the only certain thing. The data structure is the different, everything is different, even the depth, even the formation depth, the tops, everything is different about all of these LAS files. So making things compatible, it's usually, it's a little bit hard in conventional softwares, but in Python, actually what we can do is we can automate this process, either to do visualization or to collect summaries about these files, or basically just out of the curiosity, so just to see how these wells are different from each other. Of course, you can create correlations, you can create cross sections, you can basically automate anything you want, and I am talking about anything. Okay, so let me first show you how to open one of these, and then I will show you how to scan all of them at the same time. Okay, so scanning or opening one of these is not that different from scanning the whole folders for those 260 plus files. Okay, so let me show you. First of all, let's select any of these files we want. So we will right click and then go to copy path. Once we copy path, then we can set our path for this file, and you can name the path anything you want. By the way, I will go a little bit slower than yesterday, because yesterday we had lots of things to cover. Today we have only a single type of project to do with multiple aspects, of course. So the file that I'm working with is this one. Okay, so let me paste it. There we go. This is the file. Of course, it has the extension of last. By the way, it does not have to end with last. It can end with anything as long as the data structure is the same. You're good to go. So what we need to do is, in order to work with LAS files, we have a very special library that specializes in this topic, which is basically targeted for petroleum engineers, geologists, and geoscientists. Okay, so what we will do is import Lasio. So Lasio is the main library that we usually use for these types of purposes. Okay, so Lasio will allow us to read LAS files no matter how many files we want. This is the logic we can control, but the important thing is we can create, open, read, export, basically do all the operations on LAS files using Lasio. Okay, so once we have our files set and we know which we want to work with, what we are going to do is we will create a variable that's called las. By the way, you can call it anything you want. You can call it by the name of the well. You can call it anything you want. I am just using a generic name. So las equals to lasio.read, and we will pass in the path of the file. Once we do this, we will run this code. There we go. Now you have successfully created a LAS object. By the way, an object in Python is a very general thing. It can mean anything. It can be any file type. It can be any data type. So an object is just a general thing in Python. Okay. So a variable is an object. A file is an object. Anything in computer is considered as an object in programming languages. So it's just a broad sense. Okay, so once we read this, let me show you how we can explore this LAS file. And you will find it very, very easy. And it's basically amazing that it went under your radar for so long. So let me show you. So let's explore the file. By the way, whenever in Python we write this hash pound, the hash pound means that we're trying to write a comment. A comment is not runnable. It's not executable. It's only there to explain something for you. So Python compiler or the Python interpreter will go blind on this line, or as a matter of fact, any line that containing hash pound. Okay, so hopefully this is understood. Now let's move to the next step. Let me show you. By the way, the last file, of course, the last file we have a structure, or we have a standard based on API on how to capture and acquisition those files. What we can do is we can go through these standards and learn how these files work. But it's very customary that last files contains a few basic informations. So the first thing, or the first piece of information that I'm going to show you and access, it's actually the header data. So if we go and print las dot, for example, information. So the information section is going to be printed, by the way. So let me show you. Let's just print the last file itself. Okay, so this is the object of the last file. If we go to last file and then type dot to view the information, or sorry, type well to view the information, you will see that you will get all the informations about this well. And this is going to be tabular based information. So this is going to be table-like. By the way, this is not a full It's not like a snapshot reading, it's an actual interpretation of the file itself. For example, you have the mnemonics, you have the units, you have the value, you have the description of these. Basically, you can take any part of this, by the way. So let me show you one thing. If you're interested in the starting depth of this logging process, so the starting depth is strt. So you will do something like .strt. Once you do this, run this, it will basically show you that starting depth of this, which has the value of 160. So if you go, for example, dot value, this should show you like the value of the starting depth. This is just for a single variable or a single mnemonic. By the way, you can do this for anything you want in the last file. So let's move forward. So this is the well section. There is one more section that usually it's on the top of the well section. So second, read version. You can actually print or show the version of the last file. So let me show last.version. It basically should show you like the version of the last file, which version it is. By the way, for oil and gas industry, usually the version are either 2.0 or 3 version, but version 3.0. Usually, by the way, we already have like the older version as well. I think it's 1.7, but I think that's out of the way now during the current logging processes. So you can see that the version is now 2.0. This is just to view the information. Actually, it does not have like an actual use case unless you want to check the explicitly a type of version before you allow it to be read. Okay. So this is the second thing. So let me show you the third thing, which is the most important thing in a last file, which is the curves. Okay, so third, get the curves. Okay, so let me show you how to get the curves. You will print last dot curves, by the way. So run this. There we go. Now these are the curve mnemonics. So let me show you. Let me scroll a little bit. There we go. These are the curves. We have the depth, we have the deviation, we have the density porosity, we have the temperature, we have the gamma ray, we have the neutron porosity. Basically, you have those mnemonics, and then you have the units. Of course, you have the description as well. So you can see you can have the access of all of these information at the same time. And do you know what's the best thing that you can do, or the most amazing thing that you can do? Is to convert this last file into a table. So let me show you how we usually in oil and gas industry do this manually. So let me show you. We will open this last file by hand. Okay, so manually open it. We will copy this header thing. So we will do a copy like this manually. This is all manual work, by the way. Go ahead and copy it, and then go to Excel, by the way, and then we try to paste it in here. Once we paste it, of course, you need to format this other because the Excel does not recognize this type of separation yet. So usually we go to data and then text to column, and then we will try to basically interpret this in a way that basically it's easily detectable. So once we select a delimiter that basically separate these files together, we will click on finish. There we go. Now you have only part of one file, even you don't have like the full file, because for the full file, you have to scroll down and basically copy everything. Now, this is regarding Excel. Most people work this way. Now, if you want to plot something, for example, what you do usually is you select 2 columns or 3 columns. Now it's time to start like having the headache to organize everything, because now the chart is not lined up properly. Now the depth is on the x-axis, so everything is a mess. Plus, you cannot have like multi-track in this. Plus, if you have like calculations, you cannot view multiple uncompatible scale or multiple non-compatible scale next to each other. So if I did my job correctly, in this session, I will show you like how to automate this process. Okay, so let me show you first. The first part of the automation is how we can extract this table without even opening the Excel and copying and pasting. So let me show you. Extract well log. To extract well log, let's call this log equals to last.data frame. Run this. There we go. With just a single line of code, now you have a table that contains all of your data. Now, this is all of your last file. It's all interpreted and it's all in its position. So you have the actual tracks, you have the column names that are proper, you have the depths that is set properly for you. Now, the only thing remains is now to automate this part of the application. So hopefully this is the basic information about the well logging and how to work with it. It's clear enough because there are lots of different things. For example, you can open a well log file and then do some calculations, like example, the porosity, the shale volume, the carbonate flag, the hydrocarbon flags, and then you can write it back to the same last file or generate a whole new last file out of it. Or you can just export it to Excel directly. By the way, since we convert it to a table, we can do something like this, log dot to Excel. We can export it to Excel. By the way, we don't need to open Excel at all. We just export it with a single line. Okay, so this is just like the basics of what we can do. Now, let's move to the heavy stuff. Okay, so let me save this file. Okay, so what I'm going to show you now, I am going to show you an actual workflow that you can combine, manage, view, calculate, name it, whatever you want. The thing that we are certain of is we want to work with multiple files at the same time. This is the only thing that we are certain of. Okay, so let me show you the setup. First of all, what we're doing is we're importing a bunch of files. Okay, so a bunch of libraries, and then we are setting the path to our last file. By the way, even the path to your last files, it can be dynamic. It does not have to be static, by the way. Okay, so what I'm going to do next is I'm going to have the settings of the application. By the way, I already have the settings written, so we don't waste much time. The setting is something simple. It's just the names of the files, the shape, oh, sorry, what the application looks like, and the main titles. This is all to it. Okay, so I will do settings dot setup application. So once we set up the application, what we can do is I will launch this application as a server. By the way, in Python, whenever you run a server, this server is also accessible from other machines, by the way. So at the end of the session, I will show you how to access this from my tablet as well. Okay. So once we set up the application, so let me just do a quick run of the server. It will just take like 10 seconds. There we go. Now this is the application that, or let's say this is the template of the application, by the way. So the application is empty so far. It only contains one thing. It contains a label or a title, and it contains an area for our settings. You can, by the way, you can collapse and expand the settings, by the way. You can, of course, have like a different icon to this. You can change anything you want from it. By the way, Python icons, it's very friendly. Those are just emojis. You don't have to like design an icon or something for this. This is just an emoji. Let me put everything side by side so you can have a better look at this. Okay, so once we have the settings, now it's time to move to other parts of the application. What we want to do is we want to scan those last files. Since we have like our folder set up, what we can do is we can create a scan process. So let me show you. Scan the last files. So I will be using files equals to settings dot scan underscore last files. So I've created this function where it allows me to scan any number of files I want. It can be 100 files, it can be just one file, it can be even up to 10,000 or 20,000 of files. As fast as your PC goes, you can scan as many files as you want, by the way. We will pass in, we will tell it to scan this path that we have set already in the line number 7. Once we scan those paths, let me show you what we can do. We can output the scanned, or we can write to the screen the scanned files. By the way, anything you write to the screen, it's basically its last path. It's not path, it's last path. So let's make that right. So last path, save it. There we go. Now, what did it find? It find all of these files. Now, do you see it's changing? Those are basically still being scanned. So we have found all of these files that end with last file. By the way, The scanning rule or the scanning condition, I have told Python to meet only one condition where the end of the file is last. So this means that if you have combined or commingled files with different extensions, you will only get last files. And this function is very flexible that we have written. By the way, we usually teach our trainees to do such a thing. Okay, so usually we teach them how to deal with such conditions. And so what we are getting is we are getting the last name. Okay, and we're getting the full file path. Of course, you cannot use the name to read files. You need the full path. Okay. So now we are certain that we have those files. So we can pause this or from printing because you don't want everything to be cluttered. By the way, whatever you see on the right-hand side on the screen, this is the full application. So this is going to be an interactive dashboard that anyone in your team can use, by the way. It's not, by the way, the thing that we are building, it's not just for us. This is going to be for many, many peoples that are going to use this. And they will be using this using the computer IP. They do not have to install anything. And I will prove this to you towards the end of this session. Okay. So once we pause this, we will refresh the application. Now everything is hidden. So we already read the files. So let me show you what we can do. The technology that, by the way, the technology that I'm using today, it's called Streamlit. So if you go online and search for Streamlit, you will find this page. You will go and view the results. By the way, we get almost monthly updates, so this is great. It basically shows you how to use Streamlit. By the way, all our trainees from all our previous batches in all Python trainings, they learned this technology. This technology released in 2019, and to be honest, this is a game changer in Python. It will convert your boring data into an actual dashboards and visualization that you can push to your colleagues so they can use an application. So let me show you. For example, if we go and visualize one of the applications and just see one of the applications, for example, let's see one of the data visualization applications like this. If we click on it, and it will open a website that contains that particular application. Okay, so I think this is offline now. So let's see this. So these are just online applications. By the way, you don't have to upload it online. You can also broadcast your application from your PC, which is something that we do a lot, by the way, in oil and gas setup. For example, you can interact with the map. So you can interact with the application like this. For example, you can click on it. You can actually interact with it. You can do lots of things with it. So this is basically what usually the applications look like. So let me show you how this is built. Okay, so this is the technology. So one of the things that this technology allows us to do, any type of component or any type of things that I'm going to write next, it's going to be an equivalent of a button or a select box or a graphical user interface on the screen. Okay, so let's just agree on that. So number one, what I'm going to do is I am going to show all the available last files on the screen. Okay, so let me show that. So show last files, because we have found actually many, many files. So we need a dynamic way to display these files. Maybe you will have like different files in the future. So we need our application to be accommodating for these differences. So because what we have in mind and what we teach our people in our training, we teach them to make a dynamic application, not a static one. So dynamic application will survive a lot longer, plus it will require less maintenance. We will go and do something like log. So this is going to be the log files displayed on the screen equals to, we are going to display this, and we are going to allow this to be displayed in an expansion button. So expander. So let's call this logs. And we're going to allow the user to select as many as file they want. So let me show you. So this is going to be the last file displayed. So let's save this. There we go. So let me just zoom out a little bit on both of them. So if we expand this, you will see that now we have a new section called logs. But please do not be deceived with this, because if you click on it, you will get like a bunch of last files that we have just read. So let me show you. So if we expand it like this, you will get like a full list of the last files that you have. This is interactive. This means that you can select any last file you want. For example, you can select like one, this one, this one, this one, this one. You can select anything you want. But the most important thing is also to tell the application that we want the selection mode to be multi. So we can select multiple last files together, and this can be for many reasons. It can be for comparison reasons. It can be for QC reasons, or for any reason we want, by the way. So once we activate the multi section, so we can now select safely multiple files, and you can see the many files you select, they go red. By the way, you can also activate the dark mode if this is something that you're into it. Okay, so you can also activate that. This is highly interactive. You can expand and collapse. By the way, this interface is all created using these few lines of code. Now let's move forward. Once we know what files that the user have selected, now it's time to get these files or start opening these files one by one. Okay. Before we open these files, what we need to do is we need to actually set up a plot that we compare these files together. The plot will be very flexible. As many as files you select, the many plots will show up. Okay, so let me show you how we can do it. This is done by using technology called subplots. So figure equals to subplot.make subplots. Now we need just one row. By the way, you can have multiple rows because in well logging, we usually accustomed to one row with multiple columns or multiple tracks. So the columns, we want something flexible. Okay, so we don't want to fix like 3 log columns or 4 log columns. We want these columns to be very flexible, and it all depends on the count of selected log files. So this is the main idea, to have the logs that you have selected to be the count for you. So for example, if I do write on the screen how many logs I am selecting, you'll see that the application is going to be very flexible. Now, do you see this little green, this green answer or this green output? This one, this is corresponding to how many log files I've selected. So if I select more, you can see the count is increasing, right? Why this is happening? Because the application is highly interactive. Okay, so let's switch back just to 2. And we will use this selection to create subplots or to create multiple tracks. Each track, by the way, for this example, is going to represent a well. So now the columns will be equaling to the count of the well logs. By the way, you can call this anything you want. I have decided to call it count. Okay, so once you do that, now it's time to display the on screen. So you will do something like this: Plotly chart, and we will display the figure. Now the figure, by the way, the figure is empty. The only thing we have is now the X number of tracks. So let's just visualize back to light. Now, do you see the first track? You have 2 tracks. By the way, 2 tracks already appeared. So this is the first one, and the next one is just next to it. Okay, so I will change the template on this. So it's basically, it's better visible. So update layout. So let's just update the template for this. By the way, you have many templates to choose from. I will just choose a simple template. So template equals to none. Save it. There we go. Now this template, this is the way it looks like. Now let's move forward. Once we have selected this, it's now time to get to the serious business. We need to read those files that we have selected one by one. Now we have scanned the files. The files are scanned. We know where the files exist. We know the file names, but we don't know what the file contains. Okay, so let me show you how to know what the files contain. We will create a very simple loop. So we will say for F, which is short for file, or let's say L, which is short for log, in range of any log we have, which is the count of logs we have. So this is going to be a for loop as many as files you have. Okay. Now it's time to read the files. So we will say Lasio.read. Let's read those files one by one. And the file that we're trying to read, it's basically coming from files. And we will pass in the log name to it. So it basically, it finds the file for us. Okay, so basically this is what we're trying to do. So we will call this las. Okay, by the way, this is going to be a temporary file because the content of this file is going to change. By the way, um, do not be deceived by the number of lines we write. Usually in the training, we have lots of time, so we explained this thoroughly. The main thing that we're trying to demonstrate is the workflow and how these things happen. And once we read the file, what we can do, let me show you one thing. We can do something like this. We can just output the not I, save this. Now, what you can see on the screen, what you can see is 2 log files has been read. So this is the first one, this is the second one. So these are, actually, you can also explore these, by the way. You can scroll down and you can also see the other one. Of course, as many files as you select, you will see tables on screen. So let's select, just out of curiosity, let's select 9 files. The 9 files you select, you will see 9 tables on the screen. Each table is corresponding to a last file. The important thing, the application is very dynamic, and this is the thing that you should aim for, a dynamic application. Whenever you find yourself, your application is not performing very well, or your application is very static, then there is some problem with your code, okay? So I will pause this from printing out because we don't want this to be printed out, okay? And we will make sure that this is converted to table. And now we will start plotting. I will create a very simple line chart for these plots. By the way, you can also do a full plot, which is an area plot. You can do a scatter plot. You can, of course, color these scatter. Basically, what I want to tell you, you can do anything you want with this. Let's create a curve for gamma ray equals to line. So this is going to be a line. X-axis is going to equal to gamma ray, and y-axis is going to equal to the depth. The depth is, of course, is saved in the index because index is representing the depth. Once you have the gamma ray created, what you need to do is you need to add this to the chart itself. So by using the trace. So gamma ray, now we are going to add this to the first, let's say, sorry, this is going to be add trace, not table. So add trace. We will say that we want it on the first row because we only have 1 row in the chart, by the way. And where we want it on the column of L plus 1 because the index is different. So it starts from 1, but this one is starting from 0. So that's why we are matching them. Save it. There we go. Now you have a single well showing your gamma ray. Okay, so actually we have lots of things to do, by the way. We have lots of customization. The important thing is this is very interactive. You can zoom on any section you want. You can do lots of things. Now, let's go down to the serious business. If we select 2 wells, the expected behavior will be to show 2 charts. There we go. Now this is well number 1. This is well number 2. However, this is not very organized yet. We are going to organize this a little bit better. If we select 4 wells, you should be able to see 4 charts. And of course, you can compare between those charts. Okay. I know there are a few things that are off, but we're going to fix those. You can, of course, maximize this chart and get a better view on this. You can, of course, zoom on any portion of this chart. By the way, you can do lots of things with this because this is an interactive chart. Let's put this side by side. Okay. Now it's time to actually to make this application a little bit better. First of all, it's not possible to just add those lines without giving them context. So what we are going to do is we are going to set the names of these to the name of the file because we want to know where these are coming from. Okay, so we will say that log of L is basically, or the log position is basically representing the file name. So now you can see each color of these wells is basically corresponding to a particular file. So these are the file names. By the way, you can also turn off any file you don't like. Okay, so this is also possible. This is all the files are being displayed at the same time. So let me show you one more thing, or actually a few more things, not just one more thing. If you want those tracks, for example, to contain the names of the file they represent, you can also have that, by the way. But before that, you can see there is a problem with our well logs where the depth is actually is repeated on all the tracks. So the depth, if you zoom on any of these, you can see those are unsynced. So they are basically on different scales. So what we need to do is we need to combine all of these at the same scale. We can do this by using an option which is called shared y-axis, and we will say that this is true. We will save it. You will see that a difference has happened in your chart where now your depths are very different in scale. Okay, so now the depth are all usually starting from the minimum depth encountered in all of these charts or all of these logs, and the maximum depth is the maximum depth encountered in all of these charts. So this way you know for 100% sure that you have all the charts at the same ground level. If you go ahead and select more, you can see now your scale is also changing because we are accommodating with depth as well. Okay, so let's do one more thing. We can update layout and change the height, by the way. We can change the height. So the height can be anything we want. For example, we can make this chart as high as we want, or we can make this as narrow as we want. But the idea is to have something flexible. We don't want to fix this just like this. So what we can do is we can create a slider settings for our log files, which basically is a scaling settings to make this larger or smaller. So to do this, what we need to do is we need to create a simple slider for our chart size, and we will tell it scale equals to settings dot log scale. So once we do this, what we can do is we can take the scale and use it as a height function. And now you can see you have this scale that you can control the height. So this can be representative of how many footage that you want to view per screen. You have your logs, by the way, but now your scale is there. So if you shorten this, the scale will be very short. You can display everything at the same time. But if you maximize this or you max out your scale, you will find now your well log file is expanding. There we go. Now you can see those are expanding. What you can do more is you can select any portion of these files, and all of these are going to be zoomed. And now you can view everything at your own comfort. If you also hover on any of these, by the way, what you can do is you can just read off the values as well, by the way. So the values are easily readable, by the way. Okay, so let's do one more trick. Okay, so alongside with this gamma ray, what I am going to do is I am going to create another chart below it, and that single chart, it's going to contain all the gamma rays for these wells in a single chart. So basically you can compare all of these gamma rays in a same chart. This is just one different way to visualize this. So let me show you how this is done. We can create a gamma ray chart. So this gamma ray chart, it's going to be a very easy chart to create, by the way. So this is going to be a simple figure, and we're going to combine and add everything to this. Okay, so just bear with me. We will say that gamma ray underscore chart. Let's add a line to this. So line chart, by the way, you can have like any type of chart you want. So let's do a line. And x-axis and y-axis are going to be the same. So I am going to copy everything. Okay, so once we paste it in here, we are good to go. Save everything. Check that you don't have any errors, which is good. Now, the only thing that we need is we need to visualize it. So we will say Plotly chart to visualize it. And this is going to be the gamma ray underscore chart. Save it. Maximize your up work and just scroll down. There we go. Now, what do you see? This is a combination of all the logs that we have selected. So let's just select two. If we select two logs, you will see two curves, plus you will see both gamma rays in the same chart. Okay, so if you select like 10 files, you will see like 10 gamma rays showing up. Okay, so these are the 10 and these are the 10 gamma rays. There is one more thing that you can do is you can also expand this chart, by the way. So let me show you. So we can also update this chart by updating the chart, update layout. By the way, you can have like a flexible options if you want to. So the height for this, I will make the height as 1,000. So I'm going to give it a fixed height. So once I do this, I can see now this is the gamma ray. I can zoom on any portion of this, by the way, and you can see how these gamma rays of these wells, they stack next to each other. So you can just compare it and read it like this. Of course, you can also convert those multiple gamma rays into a single file if you want to do that as well. That's also a possibility. What I'm going to do next is I am going to, instead of just showing the gamma ray on the screen, in here, what I'm going to do is I'm going to convert that into shale volume calculation. Okay. So let's create a very flexible shale volume calculation, although not the most correct one in the entire industry, but it's going to be helping us a lot. Okay. So let's just pull up the shale volume calculation. So let me show you the equation. Show shale volume. We're going to use the linear function. Of course, you can use any function you want, by the way. You are not restricted to using the linear. You can use anything you want, by the way. Okay, so let's see. So the first equation is the equation that we are seeking. So the gamma ray index or the shale volume is actually the log minus the minimum you find plus the maximum minus the minimum. Okay, so this is one equation. You can, of course, use other equations as well. Mr. Nikhil, if it's possible to open the chat box for people to start asking technical questions. So because we are actually heading towards the end of this session.
Sure, sir.
Okay, so let's convey this equation. What I am going to do is I'm going to write a very, very flexible equation. Since we have different gamma ray readings for each well, what I'm going to do is I'm going to evaluate these minimums and maximums on the fly. So let me show you. So I will create a variable called minimum gamma ray. So the minimum gamma ray equals to, now just see the beauty of this. You will use las.gamma ray.minimum. That's it. It will find the minimum value for you. I'm not telling you that this is the best solution in the world, but this is close enough. Of course, you can optimize this further. We can do also something like maximum gamma ray equals to las.gamma ray.max. Now, this is the only thing we need. Now it's time to calculate the shale volume. So shale volume equals to, so maximum gamma ray minus minimum gamma ray, which is the clean one. By the way, you have to check, by the way, those values. It has to be consistent with the industry typical values. So the readings from the log minus the minimum gamma ray. So once you have this shale volume, what you need to do is you need to just replace this with V shale, save it, and just wait for the results. There we go. Now what we have calculated is shale volume that's ranging, if you can see, ranging between 0 and 1. If you want it as a percentage, what you can do is you can multiply the full equation by 100%. So this is going to show you the results in 100%. So let me save this. There we go. Now the results are saved are shown in 100% values. So one final thing to show you before we move forward, there is also a possibility to create a fills on these charts, by the way. The chart does not have to be very dull and boring looking. Of course, you can also have the formation stops mentioned on any of these charts, by the way, if you have those as numbers. Let me create a very nice fill for you guys. So we will say that we want to fill these to the 0. So to 0, X, save this. There we go. Now you get a nice fill of your charts. Of course, you can change lots of things with this. You can do basically you can do anything with this. So let me maximize this. And now this is what our chart looks like. Now we can zoom on any area. By the way, you can also create a correlation on these or on top of these. So let me show you. Of course, you can also create like correlations using Python. That's also a possibility. But you can also move forward with manual correlations if you are comfortable with such a practice, by the way. So you can also create such a thing if that's the thing that you're looking for, by the way. So you can move forward with these types of correlations. If there is, of course, if there are correlations existing in your well. Okay, so let's just one more thing to show you before we end this. So let me just connect to Zoom using my tablet so I can show you that this application is also runnable on the network for other people to see. I am not talking, so I am just working on the tablet. So I am trying to join. So I am aware of that there is no audio because I'm not speaking. So while I am joining from the tablet, so let me try to answer a few questions. So the first question is, what's the advantage of using Python over the logging suite? We actually, there are a few advantages that Python is very good
Recording in progress.
on. So the advantages of these things is a Python can handle really large volumes of data. Plus, the workflow is more flexible. You will understand what's going in and what's going out of your things. But if you try to compare Python to like TechLog and Geolog or other softwares, usually these softwares are more fledged and they give you like more better of user experience. But the main idea of using Python is not to compare it to these softwares. We're using Python to create workflows that are not possible in these types of softwares. For example, artificial neural networks, principal component analysis, machine learning, classification, predicting the lithology type using machine learning. So all of these things, of course, some other statistical tools. These things are not possible in the logging suites. Not all of them, by the way, but these are easily achievable in Python, by the way. Okay, so I will ask you, Mr. Nikhil, to give me the access so I can share from my tablet.
Sure, sir.
Mohammed is asking, Tkinter is basically a replacement or an alternative to Streamlit. Yeah, yes, Streamlit is way better than Tkinter because Tkinter is very hard. It gives us very hard time whenever we're trying to visualize something and create, for example, applications. Plus, the application that created in Tkinter, they are not very a good look at. Plus, it's really hard to maintain. So usually, yeah, we try to bypass this and basically just use Streamlit for this, which is very oil and gas people friendly. Okay, so what you see in front of you is just a view of my Android tablet. So this is the application that we have just created. You see my tablet in front of you. I will flip my tablet to the side view, so you will get a little bit of a better view. So we can expand the left-hand screen. So basically, it will also show us the logs that we have seen in the Windows application that we created. We can expand the logs, by the way. So you can see this works the same way that we did. Of course, once we start selecting those things, for example, we selected 2 logs. What will happen is the tablet will send the signals to my PC, and my PC will start to processing this. So the processing is happening on my computer. It's not happening on the tablet. So the tablet is just there for the visualization purposes, by the way. I have also shifted this to the light view. You can, of course, also scroll, and of course, you can also do any form of zooming you want, by the way. You can just zoom on any portion of this well like I'm doing. Okay, so you can add multiple more wells you want to. So this is going to create a comparison. And if you remember, like we had the final chart below that contains all the last files, this also still exists. Okay, so let me show you one more thing. I told you already that these applications usually are processed and controlled on the Windows screen. So let me show you what I'm going to do. In front of you, there is something called digital logging suite, right? The digital logging is just the title for this. So what I'm going to do is on my application that I have written on Windows, what I will do is I will change this title to anything I want. For example, I will change it to, let's call this well log visualizer. Okay, so once I save this, the update is already pushed to the devices that are connected to this application. So 1, 2, 3, the update will happen just in a second. There we go. Now the update has been pushed to our applications. Okay, so these are basically some of the things that you can do in order to synchronize these types of applications. Of course, there are lots and lots of more things that you can do. This is just one basic calculation that we did. By the way, I will still remain at the main visualization. What I am going to do is I will, alongside with the V shell, I will also create another line chart that's going to be this time. This is going to be for example, for gamma ray. Okay, so I will try to add this chart and then push it to the application so you can see the update will instantly happen as you're viewing the application. By the way, I'm working on my PC now, so you don't see what's happening. The only thing that you're seeing is the screen of my tablet. So I am going to add return to the gamma ray. So let me add the gamma ray back. So you will see now 2 curves on each track, one for the gamma ray, one for the shale volume. Of course, I'm not saying this is the correct approach, but at least I'm trying to show you what are the possibilities. Okay, so let's save this. Now the update will be pushed to the applications. Now you can see everything's loading. Now on each track, you should be able to see 2 curves, one curve representing the gamma ray and one curve representing the shale volume. And you can see how the updates were pushed seamlessly to my tablet. Because why this was happening, because what I did is now I am connecting, or I am just visualizing all of these applications in real time. Now, this is all I have to display and visualize for today. Thank you so much for joining in. Now it's time to take some questions.